Okay, we're looking at question 10 of the practice exam we did in class. We didn't get to go over this solution, so let's have a look at this one now. We have a vector equation that describes the position of a particle. And our job is to find the Cartesian equation which describes the path of the particle. And we also have to state the domain and range at the end. So this job here is going to give us 2 marks, while the domain and range together is going to give us 1 more mark. Okay? So first off, one thing that's important to us that we need to draw on is our trigonometric identity. And this is the one that will be the most applicable to us for this problem. Okay? First thing to do is to notice that in our position vector, x is determined by this function in the I direction, and we can label y as that function of t in the j direction. So we've got parametric equations. So first, here's our 2 parametric equations in terms of t. Okay. Now, in order to apply the identity, sec squared minus tan squared is equal to 1, I need to transpose them a little bit and put them in terms of sec t and tan of t. So, by transposing, x minus 1 over 2 is equal to sec of t. And if I square the left-hand side and the right-hand side, I'll have my expression for sec squared. Same for the y parametric equation. All squared gives you tan squared t. Okay, now I can combine those two together using the trig identity. And therefore, I will have x minus 1 all squared over 4. 2 squared gives us 4, minus y plus 2 all squared over 9 is going to equal to 1. And there's our equation in Cartesian form. That will be the path of the particle defined, the position defined by this position vector. And it's going to transverse this path as t ticks on. T might be a parameter representing time. So as time ticks on, the particle is going to move along this path. And this path, if we remember, is a hyperbola. So the last part of this question is getting the domain and range. So the domain of the Cartesian equation is the same as the x values, and the x values is determined by our parametric equation number 1. So if I get the range of that function, then that will give me the domain of the Cartesian equation. So for t, that ranges from 0 to pi on 2, which is the domain of our parametric equations. Then what will I get for x? X is going to be some element. Now, between 2, minimum, maximum x. If I look at sec graph, now when t is 0, okay, I'm going to have an x value of 2 sec of 0 plus 1, and sec is just 1 over cos. Cos of 0 is the value of 1. So that's going to give me a 3. When t is 0, I'm going to have a value of 3. What about when t is the maximum t value, pi on 2? Well, that will be 2 of sec pi on 2 plus 1, where sec is 1 over cos, and a cos pi on 2 is a 0. Okay, and so if I've got 1 over 0, then that goes to infinity. So I've got a maximum there of infinity. So minimum of 3 up to infinity. We now want to, that's the domain taken care of, we now want to get the range. So the range is looking at the range of the y function, being the y values of our Cartesian equation. So for the same x, for t going from 0 to pi on 2, I can go ahead and use the same process to determine what my y coordinates should be. And being a tan, let's see if I can do this mentally. So if I have tan of 0 when t is 0, then my y value will be tan of 0 is 0. 3 times 0 is 0 minus 2. Good. What about when t is pi on 2? My y value will be tan of pi on 2. Oh, I remember that one. That is infinity. So my range will be from -2 to infinity. And I must remember, if I've got y values go up to infinity, I must have the circle brackets there. Alright, so domain and range are stated, and we've got our Cartesian equation being a hyperbola. Find the equation of an asymptote. Now, if I remember, asymptotes are the part where the hyperbola tends to infinity, and they are straight line equations that pass through the center of the hyperbola, wherever that may be, not necessarily the origin. And they are the same equation, they have the same slope gradient, but one is positive, one is negative. So first off, I must remember the gradient of my asymptotes of the hyperbola. It will be plus or minus from the equation form. That is, if an equation of the hyperbola looks like this, this is the general form, equals to 1, then I have the gradients of the asymptotes is plus or minus b on a, so that the denominator is the square root of those values in the denominator, and then the center line, the center point where the asymptotes pass through, is my x1, y1 value, my coordinate, and that is the same as the h and k. And from the equation that I determined in the previous question, I've got h is 1 and k is 2, or -2. Okay, so I get the equation of the asymptotes using that information. And we're going to draw on this rule for finding our equations of the asymptotes. Okay, the general equation of straight line formula there. So we can see our gradients are going to be plus or minus 3 over 2, being the a and the b number. So first one, let's use for when m is equal to positive 3 on 2. The equation becomes 3 on 2x minus 3 on 2 subtract 2, so we'll have 3 on 2x minus 7 on 2. That's one equation. We do the same for different gradient, -3 on 2. -3 on 2x, and it becomes plus 3 on 2 minus 2. So that gives you an equation of plus a half. Oop, minus a half. Be careful with our little numeracy there. All right. So as our two equations from using the different gradients. Now, up to sketching. Hence, sketch the path of the particle on the axis below. So sketch is going to give us some points. Then we have to indicate with an arrow the direction of the motion. And you see that it doesn't ask for anything else. So showing all the x-axis intercepts, for instance, is not crucial in getting our result. But what is important is to show an endpoint, because from the previous question we noted the domain and range of our path. Okay, here it is. So you can see all the minimum values of x and the minimum value of y is 3 and -2 as a point, as a coordinate. So that's an important part of the sketch we have to take into account. So that lies exactly, x is 3, y is -2, right there. So make it a solid dot, put the coordinate in, and that's a +3. Alright, now another important part that's going to help us to do the sketch is we need to show the asymptotes so we're able to get an accurate sketch happening, and we need to also have some accurate curve to it. So it's not crucial to get our marks, showing the coordinates, but knowing approximately where it's going to cut the axes is important. First, let's put in our straight line asymptotes. So the asymptotes, from the equations we see we've got these numbers, our y-intercepts, very important thing to draw on when sketching. Start from the y-intercept, we'll have this one here, starting from -1/2. Okay, and then I need one other point to be able to draw my straight line graph. Now, what point do both of these straight lines pass through? It's going to be this one, the center point of the hyperbola. Okay, so let's mark that in. X equals 1, y equals -2. Right here. So that there is the center point of the hyperbola. And there's our straight line. Just carefully sketching that in as a dashed line. I'm sure you'll be able to do it straighter than I, given the circumstances. There's one asymptote. So just to ensure that we're showing the assessor that we're paying attention, let's put in the equation there. And let's do the same for the other asymptote. 3.5, -3.5 is there, and that's going to pass through the center point. A little bit like that, perhaps. Put in the equation just in case. Okay, so asymptotes are done. We've got our starting point of our path, and we know the hyperbola is going to follow this kind of curved shape and move towards the asymptote. So it will come up like that and then turn and go closer and closer towards the asymptote. And the motion will be in that direction. Okay, and that is generally the case. We can, just to think about the idea of direction of motion more carefully, and just to confirm for ourselves that the direction is the path that where we start from t is equal to 0, and then as t increases, how do x and y coordinates change? How do x increase and the y coordinates increase? And that will give us a little indication about the direction. Okay, and we worked on that, we thought about that in the previous question when we got the domain and range. T goes from 0 up to pi on 2, so that means at t is equal to 0, we had a minimum x value of 3, so it starts at 3, and then as t increases going up to pi on 2, we have x value increasing also up to pi on 2. Okay? Up to infinity. So if x starts at 3 and then tends towards infinity, we must be going in that direction. Oh no! There we go. Alright. Must be late, I must be tired, so let's stop there and hopefully that question made sense for you. Thank you.